Hi, this is Mrs. Vrobel. This is chapter 6. And in this chapter, we're talking about inorganic compounds. When you hear the word inorganic, it typically is a compound that doesn't contain carbon. Now, in this instance, this one does contain carbon, but because it contains a metal, it's considered an inorganic compound. Okay, so in nomenclature, we have what we call common and systematic names. Common names were a name that were given compounds before there was a system. So for an example of this would be N2O, which is nitrous oxide. Nitrous oxide, if you're familiar with former techniques of dentistry, they used to give laughing gas to people when they had to pull teeth. They no longer do this. Notice that the systematic name is called dinitrogen monoxide. Another common name would be water. Water, its systematic name is dihydrogen monoxide. And then ammonia would be nitrogen trihydride. The problem with common names is it doesn't tell us anything about the compound. Okay, so another example of a common name would be lime, which is calcium oxide. So the systematic name now tells us what type of compound that is. Now, there is a group called the International Union of Pure and Applied Chemistry. So they actually came up with a system for naming. And if there is any questions about how to name a compound, you can submit a name to them and they will decide whether or not that is considered acceptable by the scientific community. Okay, so there's 3 paths with figuring out how to name a compound. The first is element. So the element, it's talking about one type of atom. That atom might be bonded to itself, and we'll talk about examples of that. The second path is where you have 2 atoms that are bonded to each other, and we call that binary compounds. And then the last one is where you have 3 or more types of compounds, and we call those polyatomic. Okay, so the first type is element, and sodium, it's just by itself, so we call it sodium. Now you could have multi-atoms that are bonded to each other. An example with that would be the diatomics. Notice we call H2 hydrogen, oxygen, O2. F2 is called fluorine. Now there are some where they're more than just 2 bonded to each other. Sulfur would be S8 and phosphorus would be P4. Okay, now you could have a situation where you gain or lose electrons, and we've talked about this before. Ions are no longer a neutral atom. And in this example, we have a metal that has lost an electron, and we call this a cation. So it is positively charged. Now, you could have a metal that is losing more than 1 electron. So here we have magnesium and aluminum, and they've both lost more than 1 electron. When you name them, you keep the element name, but you add the word ion. So no longer is just potassium, it's potassium ion, or magnesium ion, or aluminum ion. Now the opposite of this would be anions. So anions will gain electrons, and here we have chlorine. It's negatively charged. By the way, this is a nonmetal, so this is to the right of the step stair. And you could have anions that gain 2 or more electrons. Now they get named differently. So in here, instead of it just keeping its name, you change the ending. So fluorine no longer is fluorine, it becomes fluoride. Bromine is bromide. Oxygen becomes oxide. So you're removing the ending and adding IDE, then the word ion. Okay, so you might ask yourself, how do I figure out what ion I have? So in the first column, we typically see a metal losing 1 electron. So this forms a cation. In the second column, it's now losing 2 electrons. So this metal group has lost 2 electrons. Now the only one in this column we're looking at is aluminum, okay, and that has lost 3 electrons. Now in the transition metals, they actually can lose more than 1 electron. So we're going to talk about the different charges that you can get with transition metals. Now in the nonmetal section under nitrogen, notice that those elements gain 3 electrons, so they have a 3 minus charge. In the oxygen group, they gain 2 electrons, so they get a 2 minus charge. And then in the halogen group, they gain an electron, so they only have a 1 minus charge. Okay, so when we write the formulas, we want to have an overall charge of 0. So what happens is we combine the charge of the cation and the anion together. They will form a charge of 0. So we do a little math. And if you notice, if a cation has a 1 plus charge, the anion has a 1 plus charge, and together they have a 0 charge. Notice that we just have one of each. But now potassium sulfide. Potassium has a 1 plus charge, but sulfur has a 2 minus charge. We need 2 1 plus charges to equal 1 2 minus charge. So that's why we have a subscript of 2 under the potassium and only a subscript of 1 under the sulfur. Now the other ones are examples of polyatomics, and we'll talk more about polyatomics. Okay, so writing the formula. You want to write the metal first, then the non-metal. And you want to figure out the smallest whole number ratio. Sometimes we have to reduce it down, and we'll practice that. Then you want to make sure you put the subscripts so that they balance correctly. So here's an example. We have barium and nitrogen. Barium has a 2 plus charge. Nitrogen has a 3 minus charge. We need to make sure that together they equal 0. So in order to do that, we have to have 3 bariums and 2 nitrogens. So notice we have a plus 6 charge on the cation side, and we have a minus 6 on the nitrogen side to equal the 0. So when you write that, you have 3 barium and 2 nitrogen. Okay, so we are going to move on to the worksheet, and I will make sure that your substitute teacher has the key.